but this year, vote for science.
And a president who does not believe in science.
They don't believe in science. When asked about the wildfires in California, and the question was, the science is telling us this, you know what Donald Trump said? Science doesn't know.
We can choose to believe in the overwhelming judgment of science.
General, we look for a new law by the following process. First, we guess it. Then we compute the consequences of the guess, see what, if this is right, if this law that we guessed is right, we see what it would imply. And then we compare those computation results to nature. Or we say compare to experiment or experience. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it. So that's the way. That is scientific. It is scientific only to say what's more likely and less likely, and not to be proving all the time possible and impossible. And we always try to guess the most likely explanation, keeping in the back of the mind the fact that if it doesn't work, then we must discuss the other possibilities. Now you see, of course, that with this method we can disprove any definite theory. If you have a definite theory, a real guess from which you can really compute consequences which could be compared to experiment, then in principle we can get rid of any theory. You can always prove any definite theory wrong. Notice, however, we never prove it right. Suppose that you invent a good guess, calculate the consequences, and discover that every consequence that you calculate agrees with experiment. The theory is then right? No, it is simply not proved wrong. Because in the future, there could be a wider range of experiments, you can compute a wider range of consequences, and you may discover then that the thing is wrong. That's why laws like Newton's laws for the motion of planets last such a long time. He guessed the law of gravitation, calculated all the kinds of consequences for the solar system and so on, compared them to experiment, and it took several hundred years before the slight error of the motion of Mercury was developed. During all that time, the theory had been failed to be proved wrong and could be taken to be temporarily right, but it can never be proved right because tomorrow's experiment may succeed in proving what you thought was right wrong. So we never are right, we can only be sure we're wrong. I must also point out to you that you cannot prove a vague theory wrong. If the guess that you make is poorly expressed and rather vague, and the method that you use for figuring out the consequences is rather a little vague, you're not sure, I mean, you say, I think everything's because it's all due to Muggles, and Muggles do this and that more or less, so I can sort of explain how this works, then you see that that theory is good because it can't be proved wrong. If the process of computing the consequences is indefinite, then with a little skill, any experimental result can be made to look like an expected consequence. Now, it's strictly, as I said before, not of any importance where the guess comes from. It's only important that it should agree with experiment, and that it should be definite as definite as possible.
And you'll notice that round here is a gradual, sloping path, steadily inching its way up the mountain. And if you follow it round, you'll find that even though some bits of it are a little bit steep, you can get from the bottom to the top without ever having to jump up a step. It's a gradual, inch-by-inch path up.
Outside medical centers, thousands queue up for voluntary vaccination. Reports that vaccine is running low have been denied. As the outbreak reaches its most critical phase, vaccinations near 200,000. Calm and orderly, the people of Glasgow, young and old, are eager to follow the advice of the city's medical officers.
In one big research laboratory, they're trying to find out what makes grass green. And the answer to that question may keep us industrially busy for years.
The experiment is a success.
In any area where you're not quite sure what the right questions are, whether you're asking the right questions, what you're doing is philosophy, whether you like it or not. And the reason that a trained philosopher can help with that is that we know the history of all the tempting bad answers. It is really fascinating and even entertaining to watch really brilliant scientists start thinking about tough issues and reinventing all the mistakes of the history of philosophy.
Because of the success of science, there is a kind of, I think, a kind of pseudoscience that They follow the forms. You gather data, you do so and so forth, but they don't get any laws. They haven't found any. At an even more mundane level, we get experts on everything that sound like they're sort of scientific. I might be quite wrong. Maybe they do know all this thing, but I don't think I'm wrong. See, I have the advantage of having found out how hard it is to get to really know something, how careful you have to be about checking your experiment, how easy it is to make mistakes and fool yourself. I know what it means to know something, and therefore, I see how they get their information. And I can't believe that they know it. They haven't done the work necessary, haven't done the checks necessary, haven't done the care necessary.